So this is a hard example taken from, it's probably pretty equivalent to a hard A-level question. The first bit is relatively straightforward. That just requires us to use the formula. Using this value here to find the approximate value of the square root of 7, a little bit trickier, but still perfectly doable if you follow the rules. So firstly, if I'm going to expand this thing here, I need to rewrite it. So 1 over the square root of 1 minus 3x is exactly the same as what?
Sorry, does it say x equals 1 over 9?
1 over 7. So 1 over 1 minus 3x, I can rewrite that as a power. What would it be?
Minus half.
Minus a half. Because 1 over is minus, square root is a half. Looking at that term there, we can't expand it using the C2 formula because this is negative and it's a fraction. So that formula won't work. We can't do minus a half C1, for example. That would make no sense. So we're going to use the C2, no, we're not going to use the C2 version, we're using the C4 formula, which looks like this. So we're using 1 plus x to the power of n. If you look on page 5, as we talked about previously, the formula only is given up to x squared, and we're going to need, actually we've got 4 terms there, but if we were after the 4th term, to get the x cubed term, we extend this on by saying n minus 1, then n minus 2, rather than 2 factorial, 3 factorial. We're doing the term on x4, it'd be n minus 1, n minus 2, n minus 3, over 4 factorial, x to the power of 4. But as it only wants the first 3 terms in that expansion, I'm just going to get rid of that. Comparing the formula from the formula book with what we've got, it starts with 1, which is handy. There is a little trick we need to do to get around that, should it happen. Rather than having x, we've got minus 3x, so we need to factor that in when we do our substitution, and our n is equal to minus a half. So what we do then is we say 1 minus 3x to the power of minus a half is equal to 1, plus n is minus a half, so I'm going to put it in there like that. X is minus 3x, so that goes in there like that. That's my first term, that's my second term. The next term is going to be minus a half times by minus a half, take away 1, over 2 factorial, and rather than x, we've got minus 3x, so minus 3x all squared. It's important to put those brackets in, making sure that the whole thing is squared, not just the x, but that minus 3 needs to be squared as well. That's a classic mistake to drop a few marks. And then once you've got your 3 terms, it's just a case of simplifying it. And the simplification side of it is really just dealing with the numbers.
So 1 counts as the term.
So 1 is the first term, yeah. And then we do minus a half times by minus 3, which is 3 over 2. I'm not going to use decimals, you can, but I'm not going to use decimals, but just stick with your calculator and it'll give you 3 over 2. The next one is minus a half times by minus 3 over 2 times by minus 3 squared divided by 2 factorial. Now again, stick with your calculator, but minus a half times by minus 3 over 2 is going to be 3 over 4, divided by 2 factorial is 3 over 8, times by minus 3 squared, which is 9, gives you 27 over 8 x squared. And that's it, you're finished. So that's relatively straightforward, and it's just a case of being very careful when you evaluate the fractions that you've got there. So that's part A. Any questions about that before we move on? Look at part B. They will tell you what value to choose. They won't expect you to look at that questions and try and work out what your own value of x is going to be. And the reason for that is, the examiners, there's only so much marking they can do, and they just want 1 mark scheme, so they tell you what it is you're going to need to use for x. What you do is you swap in that value of x all the way through your formulas. So you don't just put it in this side, you need to put it into this thing as well. And in fact, what I'm going to do is I'm going to go back to this version of it, rather than use this version. So what I'm going to do is, I'm using x is equal to 1/7. I end up with, looking at this thing here, I've got 1 over the square root of 1 minus 3/7 is equal to, well, technically it should be approximately equals 2, but we get 1 over 1 plus 3 over 2 times by x, which is a seventh, plus 27 over 8 times by 1 over 7 squared. And you might look at that expression there and you might think to yourself, how on earth do you get the square root of 7 from all that? Well, that's the trick, that's a hard bit of the question. You just have to look at this thing here and just keep playing with it, and eventually you'll see some relationship between that and the square root of 7. So looking at this thing here, what can I write? How can I rewrite that slightly simpler? 1 over the square root of 1 minus 3/7 is the same as 1 over
Square root of 1 over
4/7, good. And then we could evaluate some of that bit there, so you get 3 over 14, 27 over 8 times 1 over 7 squared is going to be 27 over 8 times 49, which 8 times 49,
Everyone got into that.
308.
Sorry.
392. So, looking at this thing here, how can I rewrite this 1 over the square root of 4/7? I'm going to go up here now.
4, 7, 9,
Not quite, no. You could rewrite it as a power, that's true, but I want to keep evaluating it. So 1 over, what does it do to the fraction? Flips it. So I could say that's a square root of 7 over 4. And then you've got 1 plus 3/14 plus 27 over 392, which I'll use in Joe's graphic. Thank you, Joe. I would just shove it all in my calculator, but I was going to try and do as much as I could in my head. But I'm struggling now. We end up with 503 over 392, which is great. So looking at this fraction here then, if I split that up into 2 square roots, I get on the top root 7 over root 4, brilliant. And square root of 4 is 2, correct? So we get square root of 7 over 2 is 503 over 392. And then to get my square root of 7, what do I do next? Times by 2. There'll be a bit of cancelling down that will happen there, and you end up with 503 over 196. So that's my approximation. Now, if I were to see how close, the question doesn't ask for it, but sometimes they say give a percentage error in the approximation, then you can evaluate. We'll do that in a second. Case of question.
When you times it by 2, how did you get 503 in 1 answer?
I just took in the calculator, but if I did it longhand, I've got 503 over 392 times by 2 over 1, and that 2 cancels with that to get 196. So if I was required to do a percentage error, let's just do that. It's not going to be exact, is it? Because if you remember, I've cut it off at the 3rd term. This really carries on forever, so there'll be more and more terms. They get smaller and smaller and smaller to make smaller and smaller difference to the actual answer. So let's have a look. Square root of 7 as a decimal is 2.6457. And obviously that goes, I'll just put what the calculator's got, I think. That goes on forever. 503 divided by 196 as a decimal is 2.563265. Let's just leave it at that. But it does go on as a recurring decimal much, much longer than that. So looking at it, they're not a million miles away from each other. And if I do want a percentage error, I would do the real value, take away the approximation, divided by whatever the real value is, times by 100. And if I did that, so square root of 7 minus 503 divided by 196 over square root of 7 times by 100, and the percentage error is 3% error. Now with more terms in my expansion, the error becomes less and less and less. And the reason why this is important is because before they had calculators, before they had decimals, before they had any way of working things out, they used to use this binomial expansion to get fractional approximations to square roots of things. And they could have used that, it's only 3% error, and whatever calculations they were doing might have been accurate enough, but obviously with more decimal places, there will be more accuracy.
Do we need to know how to do percentage?
I'll put that percentage error in there, might be handy, but it's just, as I say, the real value minus the approximation divided by the real value, and then make the percentage times by 100.